Good evening, everyone, and welcome to a tradition at the AP Statistics reading, and that is Best Practices Night, where we get some of our best and most talented folks to come out and make some presentations on the great things they're doing in their classroom. Feel free to share these, grab them, take them home, steal them if you would, and use them in your own classroom. Bob, these are going to be on our website. Yes, tell us about it, Bob. It is the Math Coach blog. So if you go to Math Coach blog, you will find all of these presentations and past presentations as well. So look those up, please. Bridget?
We have a great lineup tonight, but they're only 5 minutes long, supposed to be. So if you're sitting there watching a presentation and it's like, oh, that's not my cup of tea, that's fine. You just hang out for 5 minutes and wait for the next one. But I promise they're going to be amazing, so you don't have to really worry about that.
And I forgot to introduce us. This is Bridget Matamoros, and I am
Darin Clifft.
Darin Clifft. Okay, let's get started. Thank you very much. I am from Memphis, so I am contracted naturally to say it that way and to end with, Here we go. First up is Young Saver. I think I said young too many times, but here we go. Dash, come on up, buddy. You got first.
Hello, statisticians. My name is Dash Young-Saver. I'm an AP Stats teacher in San Antonio, Texas. I'm also the founder and CEO of Skew the Script, and today I'm going to talk about measuring causality in education. Maybe we'll be talking about it today. Wait, I'm 2 minutes in? That's not possible. Okay. All right. Oh, okay. There we go. They just really want to Hulk me. It's fine. So how do we know what works in our classrooms for teaching statistics? Well, we all know. We try things every day. Every day is like a new experiment with our kids. We see what works. We see what works with our style. We see what works with kids, and we move on. But how do we know what works at scale for teaching statistics? At scale, well, as stats teachers, this is a causal question. And so when we ask causal questions at scale, what do we want to do? An experiment. Yeah. So at Skew the Script, we were wondering for our open source, free, relevant AP Stats lessons, do they actually have a causal effect on AP Stats scores? There's been thousands of teachers across the country downloading our lessons. Do they actually have a causal impact on what happens on the AP exam? So our idea was we're going to take a bunch of classrooms, a bunch of students, randomly assign those students to either do a Skew the Script curriculum or to do not a Skew the Script curriculum, and then wait a whole school year, and then see which group does better on the AP exam. And districts told us no, because that is just not how school systems work. Schools don't randomly assign students or teachers to curricula for a good reason. So we had to do something different. And so we did what's called a quasi-experiment or a natural experiment. These come in different flavors, shapes, and sizes. The one we chose, and by we, I mean the research group that we corporate partner with at Harvard, Dr. Eric Taylor, who's an economist at Harvard, we chose to do a diff and diff study, difference and differences. This came out just last week of May, so this is hot off the presses. I actually changed my whole best practices presentation to fit this because this is new results, and they just released their brief. The difference and differences approach is best exemplified by a graph like this. So on the y-axis there, you'll see the pass rates in AP Stats. The x-axis is the school year, and you'll see two schools charted on there. The school on top is a school that never has used Skew the Script. The school on bottom is a school that eventually used Skew the Script after it came out in 2020. They started using it in the year 2022. And you'll see that at baseline, these schools already have very different pass rates in AP Stats. But keyly, one thing they do have is parallel trends. Year by year, they have similar ups and downs in their AP Stats pass rates. And so if you can find enough of these schools that match up closely enough, you can chart out those parallel trends and wonder if parallel trends had continued, if that second school, the bottom school, had never started using skew the script in that counterfactual world, what would their AP Stats pass rate have been given what it was in the school that never used skew the script? Then you look at how they actually performed, and the difference is the treatment effect. You have to also satisfy other key assumptions that I can't get into in 5 minutes, but this is the basic idea. And if you do this for enough schools and you find enough and get a high enough sample size, you can find the treatment effect of skew script. This is what ideally would happen. And then they collected the data. So they performed a difference in differences analysis, analyzing AP Stat scores from 125,000 Texas students from 2014 to 2022. We started in Texas because Texas is our home state. And here is what they found after doing all the school matching from a lot of schools. They found that we did, in fact, have a causal impact on AP Stat scores across Texas. Our curriculum boosted causally pass rates 10 to 11 percentage points after 2 years and more of use. That was statistically significant. The confidence interval did not include 0. And as far as we know, this is the first ever research of curricula showing causal improvement for AP Stat scores, a course that's been offered for almost 30 years now. So this was the big result that we had. And we wanted to also do some key assumption checks. So for example, it could be that schools that started using skew the script also had other school-wide changes happen coincidentally at the exact same time. What if a leadership change happened across those schools? What if they got new PD programs at the exact same time? Well, you would expect those things to also show up in other subjects, such as AP English Language and AP Calculus. You would expect those to be school-wide effects affecting other AP courses. They looked at those courses, no change in either subject. The only change was in statistics, where we had our curriculum. We also wanted to see that this change wasn't happening at the same time as a change in enrollment in AP Stats. Because if you're raising pass rates, but fewer kids are taking AP Stats, that could be a function of fewer kids being in the course, rather than a function of actually raising achievement. They found there was no change across treatment and control schools. It was the same pattern as usual in terms of enrollment. So this gives us even more confidence this was a causal change in student achievement. My main point in saying all this is one, to celebrate this, but also to say that we're going to dig deeper, we're going to do more causal research across more states and keep on doing this work, and more importantly, us as a field, the field of education, we need to do more causal research. The field of education is miles and miles and miles of correlation with an inch of causation. We need to get better at this. We need to know what actually works at scale, and us in the stats education community who value... Thank you. Us in the education community who value rigor in data methodology, we should lead the way. Demand of your school systems causal evidence. Demand of your curricula causal evidence. Demand of everything that touches your school causal evidence.
Make Hulk angry. You not like Hulk angry.
Thank you. So if you want to check out a blog post we have breaking down the full results, you'll see it at this URL. And it goes into all the stuff, including Massachusetts schools and other things we've discovered through this research. Thank you all so much for your time. Really appreciate it.
Okay, let's see who is next on our list. I'm going to close this one out. Next up is Aryn Hinkle. Aryn, come on down. Erin, have at it.
Okay, I'm coming at you from the frozen tundra of table 23. Okay. I think this is my favorite night of the reading. I learn something new every year, and so for those people who are newer, I wanted to share 2 best practices nights ideas that I still use in my classroom every day. The first came from 2015 reading in Kansas City. Michelle Larson presented on Multiple Choice Monday. And the way I use it, every Monday I give 5 multiple choice questions at the start of class. My students work in pairs. You can see my desks are paired up. That encourages collaboration and discussion among them. After 10 minutes, I use flippity.com to randomly select students. If you're not familiar with Flippity, this is also a great way to randomly put students into groups. If you like building thinking classrooms, I encourage you to check out flippity.com. Then we discuss their incorrect responses. We find out what we need to know about those problems. I make sure the questions include new content and review, so it's a spiral. It, again, promotes retention, allows me to do less review at the end of the year because we've been reviewing all along. And because we've been reviewing all along, it keeps them engaged. Even though it's not for a grade, they understand the value of it. They understand that we're reviewing as we go. The other presentation that I use is Thomas Young's Casino Game Day. I think Adam also had a similar presentation in years past. I changed it to the Carnival Project. I have my students, after the probability unit, they work in a group of 2 or 3 to construct a game of chance. It does have to be a game of chance. They always want to do like throwing darts at balloons, and I say we can't use that because you can't predict the probability of success. I encourage them to use dice, spinners, cards, that kind of thing. Then they turn in, before the carnival, they turn in a written report that describes their game rules. They have to give me their rationale. We play with fake money, and they have to tell me how much they're going to charge, how big their jackpot is going to be. They have to rationalize that their game will be profitable in the long run. They have to give me every possible outcome of their game and the probability that goes with those outcomes. Then they actually build their games. They get really creative. They make spinners out of fidget spinners. They make their own dice. They make their own lottery scratch-off tickets. They wear costumes. They get very excited. They really get into using their teachers in their games. And so this was a game where you were trying to see if the teacher would pass the dress code. We set them up in the gym. I do give prizes for the teams that are the most profitable game, and we vote on the fan favorite game. And so to encourage people to come to their table, you see a girl wearing a chicken costume, and they just do whatever they can to get to their game. The event is so popular, so I'll invite other teachers to bring their classes down, but it's become so popular that I have to keep people out because too many people want to come down and we just can't handle it. And then afterwards, what went well and compare the actual mean to what they predicted it was going to be. And depending where you put this in the year, we do it on our senior's last day of school, but you could do it right after the probability unit. So that's it. Thank you.
All right. Next up, we have Nick Simonetti. Let's get that pulled. There we go.
All right. Hey, everyone. My name is Nick Simonetti, Father Acorn. Acorns in the house. Raise your hand. Yeah? Great turnout. Great turnout. Acorn Skit's going to be great. I'm looking forward to it. I'm a math teacher at Cornerstone Charter Academy, and today I am talking to you about ditching retest and test correction. So I don't know about you all, but for me personally, I stink at doing test corrections and retests. I've been teaching now for 13 years, just wrapped up year 13. I've been teaching AP Stats that entire time. And I always feel that it is transactional and doesn't focus on the learning, which is what really matters. And I know it works because there's teachers in my school and people that I know do test corrections and retest really well. I just stink at it. My problem, I need to figure out a better solution. So what did I come up with? I came up with something that doesn't really have a cool catchy name, I'm sorry. It's called Group Test Analysis Approach, all right? So really quickly, because I only don't, 4 minutes left, what happens is after they take the test, right, they come into the classroom and they are randomly put into different groups and they work out the test again. They do not know their test grade. I didn't grade it, obviously, yet. It's way too quick, right? 24-hour turnaround. They don't get their physical papers back. they get a blank test, and they're in groups of 3 or 4, and they're working on it together, collaboratively, one question at a time, okay? And what I've seen here, I'll give you some very anecdotal data later, but the conversations I'm hearing when we do this is just so amazing. It's really great, and it focuses on the learning and not the grade, because I'm all about process over product, and they can explain why they arrive at a certain answer and not trying to remember, oh, the answer was C, or this is, what the answer was. They're completely working together on this as a group, and I love it. So again, the benefits, I just talked about that. I do have rules when we go through this, because kids will be kids, right? They try to divide and conquer. I'll hear this. Oh, I'm going to do number 1. I'm going to do number 2, and then we'll just, no. You're all going to collaborate on this and work together one question at a time, and everyone's going to bring something to the table, right? Not just one person is going to do all of the work, all right? So I have to monitor the room and make sure I hear what I want to hear, okay? And this ultimately leads to a deeper understanding of why behind those concepts and why they got those questions wrong, because I hear them say, oh, I just realized why this answer was not 13 or 12 or whatever, and they can now fundamentally understand better of why that happened, all right? And I want to get to the random group assignments, because this is like radical, right? Because typically when I was doing this before, or in my years of teaching, you would think like, all right, I'm going to put the high test taker with the low test taker so they can get, help or whatever and learn from each other. When I try those things, again, my problem, that didn't work, right? So I did random group assignments. And I do want to shout out one of my friends here, AP reader, Vanessa Hackett. When I talked with her last year at the reading, because one of the best things about the AP Stats reading is to collaborate and learn from people like yourselves who are amazing. And she introduced me to a website called Classroom Screen. Definitely recommend checking it out. I do like the website that was just posted, share with us. That's really awesome too. But this dramatically simplified and saved me so much time randomizing groups. Fun fact, every single day when they come into my classroom, they are in randomized groups of 3 or 4, and it's so much fun. And they learn very quickly, like, oh, I can't rely on, Dash to, do the whole thing. I got to take responsibility of my own learning. So it goes away from, that to let's lock in, as those kids say. So again, it takes the ownership of learning on them, and the conversations out of here is just really, really remarkable. And 95% of the groups are at 100%. So I grade these again, so it creates more grading, but very little. And they all do really well on it. And the percentage of students who don't earn A's, don't earn on 100, they earn an A. So as a disclaimer, because kids are kids and they need to be motivated, I count this as a minor assignment. So in my classroom, I have 2 buckets. I have a major assignment bucket and a minor assignment bucket. So this goes in with all the other completion grades. So that's how I do it. And they are very eager to come in to see who they're working with. And it's just a really awesome experience. So overall, I've really enjoyed this sort of radical sort of shift in
Hulk smash! Hulk smash!
in test corrections and retests, and the kids look forward to it. They really do. And so let's revolutionize the post-assessment learning together, because learning doesn't stop after you take the test. And yes, this is something you can do in any class, not just AP Stats. Thanks so much.
Great job, Nick. Appreciate it. Thanks a bunch, bud. Thanks a bunch. Okay, let's see who is up next.
We have Mikel.
Mikel. Let me find you, Mikel. Here we go.
She's in a rock band, guys, that performs on the weekends. The name of her band is called the Alan Rossman Project. You should check it out.
It is not. No, it is not. The Alan Rossman Project is copyright Darin Clifft Enterprises, not to be used without express written consent of Darin Clifft and/or one of its subsidiaries, 2025-2026.
All right, so I'm going to sing. It's going to be wild and crazy. So thank you to Erin and Nick for planting the seeds for my topic today, or giving you a teaser. I'm going to talk to you about daily randomized grouping. And I teach in a high school math classroom, specifically an all-girls high school math classroom in Houston, Texas. So what is daily visible random grouping? It's the process where you create groups, small groups, usually 3 is ideal, for your class each day in such a way that the configuration of these groups is completely random, which we're all pretty good at doing. And that strategy for random assignment is visible and clear to your students every day. So the students are coming in every day with new seats and new groups, and they know that it's random and that you're not just making it random as they walk in. So what is the point of this? And just to echo what a few of our best practices presenters have already said, this is really going to foster a collaborative learning environment by organizing students into problem-solving groups, either before or after some formal instruction or for any other activity that you're doing with them. What I have found as the biggest benefit for me is that it really prevents this stagnation. How often do we have students walk into class on the first day, sit down, and then they will come in and sit at the exact same seat every day if we let them for the rest of the year? So it really prevents that stagnation, and then it gets them working with different people in the classroom regularly. I also think that it's very beneficial because it gives students some experience with these real-life random events. I'll have a student who will come in, and go, oh my gosh, I got the same seat 5 days in a row. Like, how is this random? And it's like, that is sometimes what happens. So I think it gives them a great opportunity to experience what that feels like. So how can you do it? A couple other folks mentioned some great websites, Flippity, and I really like an old school one called randomlist.com. And it's a team generator. But I actually prefer a more analog approach. I just take some popsicle sticks or note cards and write my students' names on them, and then I will shuffle them up, mix well, and then place them on the desks, or I'll ask students to, hey, come over here and randomly pick from this group, 3 popsicle sticks to set down on this desk. And then when students walk in the classroom, they're seeing their peers randomly draw these popsicle sticks, and they're looking around for their seat for the day, and it just kind of gets them moving. You can also use, a random integer generator, like Randint on the calculator. You can come up with a lot of different ways to do it. So some unintended or intended consequences are that you're going to get students working with all kinds of individuals, and they're going to learn to assume different roles within the group. They can be a leader, a facilitator, a scribe, a reader, and this is going to happen usually naturally, or you can assign these roles to your groups. Some groups are going to have a great day. They are going to vibe, and it's going to be amazing, and some groups will not. And that's okay. You can offer some support to them, and you also might never have to worry about creating a seating chart again. So about that support, I really find that it's helpful in your classes to get your students talking to one another at the beginning of class about something that has nothing to do with what you're actually doing that day. So I have this game called Charty Party. It's like Cards Against Humanity, but with graphs. It's pretty fun. So we'll use that. You can do this or that questions, Hawaiian pizza or pepperoni pizza. Would you rather? I have some table topics questions that I got from a kid's meal at a Chick-fil-A that we use. And then I have these other connection cards that are really more about social emotional learning. But keep it simple. The important part is to have fun and get kids talking. So however you do this is going to be great. So I hope that you're now interested and looking to take random grouping for a spin. My students in data science, thank you for listening. You can see they're very excited about their popsicle sticks. All right, thanks.
Thank you, Mikel. Fantastic. Appreciate it. Appreciate it. Okay, up next is Oscar. Come on down, Oscar.
Hello, my name is Oscar Aguirre, coming from the very far, far away land of Miami, Florida. I will be presenting on the upcoming project-based learning series that's currently in final stages of development for AP Statistics. First question, of course, is what is PBL? The acronym, of course, for project-based learning. The most important thing to think about with what PBL is, it is that it is an instructional approach. It is not just throwing projects in at different units at different times because we feel like it, because it's fun, but it's an instructional approach where projects are driving the learning and the instruction in your classroom. It is a very large transformation that happens in your classroom, but it is something that does lead to significant student engagement with real-life data. So what project-based learning starts with is, of course, a challenging question or problem, and I'll introduce very briefly the AP Stats series momentarily. Once you have that challenging problem or question, you go through a process of sustained inquiry, peer reflection, revision, critique, using authentic data sets in the ultimate pursuit of creating a final product that encapsulates their learning in that particular project. And so our series has 5 projects. If you know teachers in other subject areas that have the PBL series, for example, AP World, AP US Government, AP Environmental Science, us and AP Human Geography are the 2 courses that are finalizing our development this summer. For AP Stats, we have 5 different projects. The first one is called Best Picture. So in this project, they deal with a spreadsheet that compiles data from the Academy Award Best Picture winners, and using their understanding of data analysis and data collection, they answer the driving question of how can data be collected, organized, and analyzed to create an award-winning film with the ultimate creation of a promotional product for a film of their choosing. The second project is titled Career and Income. This one focuses on probability units using data from the Bureau of Labor Statistics to answer the driving question, what variables should you consider when choosing a career? The third project is called Machine Learning. This one uses plant identification apps and focuses on inference for categorical data such as z-intervals, z-tests, and chi-square testing to answer the driving question, how can statistics reveal the benefits and drawbacks of machine learning and artificial intelligence? Project 4 is called Air Quality. This one focuses on data collected from the Environmental Protection Agency on pollutants in the air and using inference for means. The driving question is, what can we learn about specific geographic locations based on their air quality? And the final project is Project 5, the Happiness Index, using the annually released World Happiness Report, using correlation and inference for regression to answer the driving question, how can ideas like happiness be measured? And so as an instructional approach, why is this something that we would consider kind of transitioning to in our own classrooms? There's so many different reasons, but due to the 5 minutes, I've chosen the 3 big ones that over the past 3 years that these projects have been in development. These are the 3 that consistently have come up from those of us that have been kind of piloting these programs in their development. The first one is huge engagement from the students since they are seeing authentic data consistently and it's following kind of a track throughout the entirety of the project. We have major boosts in student engagement and of course, increasing that accessibility to our course content to a broader range of students. The course currently is covered, about 90% of our course material is covered throughout the 5 projects, and so because it's fairly comprehensive in its coverage, not only are they doing what needs to be done to prepare for the AP exam, but they're also doing it in a more engaging way. And then lastly, this is something that we've heard from teachers, even though I've only been teaching for about 5 years AP Stats, we have in our pilot group teachers that have been teaching for 15 plus years. And those teachers that have piloted this approach have, all 3 of them, we're a very small group, it's 9 of us, all 3 of them have said that this is something that reignited the passion for the course for them in their classroom after having taught it the same way for many, many years. And so if you'd like to learn more, there are several avenues for you to potentially learn more about our series. The first is, of course, the AP Summer Institutes that are happening starting this summer in a couple of weeks. There are both in-person and online ones, so look out for those registrations. Those are still open until a week before they start. After participating in those APSIs, you get access to the full training as well as all the project materials for each project. At the AP Annual Conference in July. Hulk smash! I'm going to finish Hulk. Thank you so much. For AP, at APAC this year in July, I'll also be presenting a longer session on July 17th, focusing on Project 1 and kind of giving a bigger kind of overview of what PBL is. So if you are going to APAC or interested in joining, we have a session on that week as well. And then lastly, there are several of our PBL committee members here, including myself, Josh Argo is here. Our very own Bridget is here. And Carol Chamberlain Hebert. They're all part of the PBL Development Committee. So if you see any of us and just have any questions about our experience, we'd be happy to share as much as we can. Thank you.
Thanks, Oscar. Good job, Oscar. We're just going to welcome up Bob Lochel. Come on up, Bob.
I want to point out that Bob has been doing Darin's job tonight by doing the timekeeping, so we have fewer people being hulked.
No joke?
No joke. This fine young man right here has sat down there and has made sure that every person up here, every presenter knows what the time is, just so I can't hulk them. You're great, Bob.
We're all very afraid of Darin. So you've all had it very easy tonight so far. You're sitting here, you're watching everything, but now you have to participate, and I walk around church style. Please raise your hand if you've never heard of or participated in a slow reveal graph before, if this is totally new to you. Fantastic. You're going to be talking to your neighbors for a minute here. So let me show you a graph here. There we go. Usually I give people more time, but you're going to get 15.2 seconds. Turn to your neighbor. What do you notice? What do you wonder? And more importantly, what do you think the context is? Ready, go. .3 seconds left. .14 seconds left. All right, wait a minute, you can keep on going, but I'm going to give you more information. Here's more information. Years since being founded. What do you think it is now? Any new ideas? Years since being founded, what could it be? Notice the conversation. What's possible? What's plausible? We have more. Billions in revenue. Or is it millions? Billions in revenue since being founded. Do you have a better idea of what this is about? Listen to the conversation. Listen to the buzz. What could it be? All right. If you're really passionate, someone raise your hand if you're really passionate about what this is about. Who's got a loud voice? You can tell me what this is about. Social media. It is about social media, these different social medias. Thank you very much. And it comes from this article about TikTok. Notice the use of color. We just strip away all the labels and get it down to its essence. These are called slow reveal graphs. This is the time to get out your phone. There's a QR code there. There's a whole website with slow reveal graphs. And what's great about them, notice the conversation. AP Stat teachers, what do students struggle with the most? Context, context, context. Let's talk about plausible context. What makes sense? What fits the clues of the graph? I'll leave that up there for another 10 seconds. It'll be posted later, but there's a wonderful graph. Jenna Labe, and she also has on there a Venmo because she has to pay for a website. Please shout out to Jenna, who is not an AP Stat reader, as far as I know. I don't think she is. But it's a great time to do it. I use them as warm-ups. Let's do two more about a minute each, right? Here's another one. All right, we got some colors, just a bar graph so far. The colors might be, I think you really have to be in tune with what's going on to get the colors. There is a white bar at the end. All right, let's put more on it. Here's more. Ready for more? Here's more. Woo! Oh, oh, oh! The cries from the crowd. What could it be? But, oh, we got off the colors. We got some people got off the colors made sense. I'm not as Swifty. The colors made sense. But what could it be? But wait, there's more. The number of times the term is used. What could it be? Darren, how long do I have? 2 minutes, thank you. What could it be? There is a great article out there that takes a deeper dive into this, but this is swear words in Taylor Swift albums. If you look for it, you can find an article about the swear words. They break it down by word, and also about things like alcohol consumption. Yeah, Taylor got a potty mouth over the years when she became famous. There it is. It's Taylor Swift. All right, we got one more. Ready for one more in 1 minute and a half? Dot plots. Dot plots. What could it be? What will your students say? What is a plausible context for comparing these two data sets? What could it be? Got a bunch of dots on the low end. The one's more spread out. Let's give a context. Numbers. Oh, I almost gave it away. Oh, 0 through 70. What could it be? What will students say? These are yards. Yards. What could it be? These are yards. What is this? Oh, I hear Josh Tabor. Discus and shot put. Some people are just dropping that shot put down. Length of rushing touchdowns in 2024. Here comes your last one. Who could it be? It is Jalen Hurts and Saquon Barkley because of the tush push. And with that, I leave you tonight with this. Go Birds.
Give it up for Bob Lochel, folks. Wow. Bob, you are definitely an entertainer. Okay, folks, the next presentation we have comes from an idea that I got from Vicki Greenberg several years ago. Vicki thought it'd be a great idea to do sort of a speed round where maybe 30 seconds, 10 teachers give their best tips in 30 seconds. You know, something you don't want a big presentation of, but hey, here's one little thing I do that seems to make a difference in my classroom. So we started sort of a pilot project this year, so instead of a speed round, we're just going to do a couple of quickies with Darin, Adam, and Luke. You ready? So here we go. Here's the first quickie. Yeah. You ready? Okay. First quickie. Tennessee Mathematics Teachers Association hosts a presentation. I'll give it to you in just a second. I'll give you this one. Host a competition every year in the spring. This is their website, tmta.wildapricot.org. And then Austin Peay State University hosts our competition repository for all our competitions. So if you go to that website or AP, if you look up TMTA competitions, you're going to get this. So there's competitions in Algebra 1, Algebra 2, Calculus, Geometry, Pre-Calculus, and Statistics. These are all competition questions, and they go back decades, and I mean back to the 1960s. You can get 40 multiple-choice tests for Algebra 1, Algebra 2, Geometry. Calculus was previously called maybe Advanced Topics 1 and Advanced Topics 2, but these are some great questions that you might want to steal and use, maybe for some inspiration. That's the first one. Adam, what do you got?
Hi, everybody. I'm Adam. So some of us love acronyms, some of us hate acronyms. Maybe you know these acronyms, maybe there'll be a new one for you, but here are 3 acronyms that you can incorporate into your classroom right away. So the first one, come on, we're not advancing. There we go. All right, so random number table simulation used to be a much bigger topic. It may not even be around a couple years from now, I don't know. But we do talk about random number table simulation. We know kids have a very tough time writing up a simulation, so we use the acronym STARS. Start, assign, ignore, repeat, stop. That is the perfect RNT simulation paragraph. I will start at the top left of the random number table. I will assign everybody in the room a number from 0, 1 to 30. I will ignore numbers outside the range. I will also ignore repeats, and I will stop when I get 5 unique people. That is your perfect simulation. The acronym is STARS. Notice the T is lowercase because it's start, assign, ignore, repeat, stop. And we know they always forget repeats. Okay, second acronym is, what is, Darin, you didn't load the right slide. No, he literally didn't load the right slide. All right, just leave it. I'll do it. Just kill it. The second acronym is the acronym for residual. What course do we teach residuals in? Say it. AP Statistics. What's the acronym for residual? AP. Very good. I must say it 50 times. Where do we learn residuals? AP Statistics. I keep saying AP so they know it's actual minus predicted. Good. Finally, what do you have to think about, Jamie, when you think about a relationship? Well, that's easy. STDs, of course. We all think about STDs. When you think about a relationship, we think about STDs. I learned regression in the 1980s. We didn't call it form, we called it type. So it's strength, type, and direction. When we think about a relationship, we think about STDs, strength, type, and direction. That's my time. Luke.
I just have one slide. You got the clock? All right, since 1997, the College Board has released over 200 FRQs along with the rubrics that were used to grade those. So we have collected all of those questions and those rubrics and put those in the Mathematic AP Stats FRQ search tool, where you can search by year, CED topic, or even the topic that you might remember from the question. How many of you remember the Choco-Zooties problem? Yes, okay. My favorite part about this resource is that there are 2 links that are provided here, one that takes you to the question and one that takes you directly to the rubric, because you always have to Google search it and find the rubric. It's all here in one spot. You can find this on the Mathematic blog. Thanks.
Great, Luke. Appreciate it, fellas. So if you are interested, maybe next year, doing a presentation in the speed round, be looking for that email, okay? We'll have that invitation for you next year. Okay, up next is... Oh, okay, yeah, okay, all right. Nothing from the peanut gallery, thank you very much. Okay, next up is Erin. Come on down.
My name is Erin Sallette. I teach at a high school in Evans, Georgia, and I am about to talk to you about March Mathness. We all have these students. They want to do anything other than what it is that we have to do for a class. So please, Ms. Sallette, let's fill out basketball brackets, specifically men's NCAA Division I basketball brackets. So we have to have a time crunch. We were very affected by Helene in our area, so whatever we did, we had to use it. So we also have a problem with young people gambling, so whatever we do, we can't encourage gambling, and there has to be prizes, though, so they get the glory and some Dunkaroos. So how do we do this? There's a time constraint. The last 4 picks to go in this bracket, the 11 and the 16 seeds, happened on March 18th and 19th, but the tournament started on the 20th. So you gotta print, you gotta plan, you gotta get this going. You can use these track sheets. They're available online, pretty easy to find. You can also find PDFs of the brackets from the NCAA website. You need a survey, and this is where we make it kind of a little bit different because this is not a number, but we're gonna make it a number. I asked 4 questions. My 4 questions had to do with number of games that you watched, the amount of analysis that you watched, your personal knowledge rating, and your personal enjoyment rating. Here are the data. We had 73 faculty, staff, and students participate at my school, and we have over 2,000 participants that are eligible, so we didn't take too large of a sample here. If you'll notice, we have a bit of crowding at the lower end here. There about 60% of the data have a score of 2 or below. But I have a guess as to why that happened. But we do have to talk about the random selection condition, so we basically could only conclude about whoever had the opportunity to participate. And we have a little bit of a large variety at the lower end and less at the upper, so we'll talk about that later. Here are the results in terms of the analysis. As far as our test review for this particular unit, I had people perform a linear regression t-test on their data, and it was fun for them to have something that they participated in to use. And then we also had to discuss, well, what does a basketball knowledge of 2 mean? Because I made it up and I'm cheating, so that's okay. But it does feel good to reject a null hypothesis, and we got to do that. So this also kind of brings us full circle to the gambling issue. Oh, all I have to do is watch a bunch of games and I'm gonna win a bunch of money. No. No. Correlation is not causation. I hope you learned that in my class. But we did want to analyze the results. I had 2 faculty winners, they tied, but they had a large basketball knowledge. And then I had 4 sections, so 4 student winners. One of my student winners had 52 out of 63 correct bracket predictions, which puts her at the 80th percentile for brackets. But she had a basketball knowledge score of 2. So how did this happen? I asked. And she asked for help, which I didn't forbid, so that's on me. So I said, you know what, we'll add another question for next year. How many games did you get outside assistance for predicting? Moving forward, this is kind of disappearing from our curriculum. You can use this next year.
Hulk smash!
We can smash it next year. We're going to change the survey. We're going to add that question. We're also going to open up to other tournaments. We had people interested in making sure that we use the women's tournament. Excellent. I'm currently doing Roland Garros with my husband. I'm losing. And then it also leads to discussion for extension topics. So it's a great way to add it in there. And thank you.
Good job, Erin. Appreciate it. Yes, ma'am.
Thank you, Erin.
Okay, who is next, Bridget?
Penny Smeltzer.
Penny Smeltzer. Smeltzer, come on down. Lessons that matter. Fantastic.
We all have our own priorities and passions, like family, and I like to travel, do some photography, turn it into lessons. I've always wondered why science and math teachers don't talk more, so I spend a lot of time talking to science teachers and integrating what they teach me into my classroom, and I'm passionate about the environment. My good friend, Dr. Joy Killo, and I decided the best thing that we could do for the environment was to write lessons for students that actually work in our classrooms and integrate it with math and science and put it out there for people to use. We call these lessons lessons that matter, and if you Google lessons that matter, it's the first thing that comes up. When you click on it, here's the home page. You have some choices along the top. If you go to the statistics page, I have written one example problem for every single lesson, and when you click on it, there's a student sheet that you could pass out to your students, and then there's a PowerPoint that you could use to follow along and talk, and that's where I put some of my photography that I'm playing with because that's fun for me. And here's an example. If you're on question 1 for my Unit 1 lesson, it's about nitrogen level in fruits for animals in Madagascar, specifically the lemurs. And you can see that the A part, you compare or talk about the differences in the distribution. For the B part, using the information in the box plot, you have to make a decision. For the C part, different box plot, slightly different topic, and you're asked to judge in which area would climate change have the most effect. After you get done with the lesson, then there's the scoring guidelines. The lemurs were cool. So there would be the question, and then some very similar to how we score here. the scoring guidelines that you could use right with your students in class. If you go to the integrated lessons, those are the lessons some of the lessons that Joy and I have done where we get our biology and statistics students together in the same classroom, and we're doing a lesson that's a little more active. You might need dice, you might need cards, you might need something, and they're actually doing something together that applies to both science and math. Sometimes when you click on a lesson, it's going to say almost there, but you can't have the lesson yet. And that's because teachers have told us that they want some things protected that the students can't see, particularly things that they could use for assessments. So then you have to register in order to get the lesson, and we're just having you register so that we know you're a teacher. And we actually look on your school website. I have called principals and said, who is your biology teacher? And they tell me the name, and I go, thank you very much, and I click them through. When you register, then when you look on the statistics site, more things show up for you. For instance, you get my free response rewrite questions, where I've taken a free response question in every unit, rewritten it with different context and different numbers, and then I give them as 12-minute quizzes in my classroom. You will get some stat labs, things that I do that are more active learning. There's just a little bit there. This website is not done. I'm writing all the time, but if you get there, you will get more and more and more as I write more and more and more. Also, I've been working on mini AP exams. These are 30-minute exams that have 1 free response question and 8 multiple choice questions. So if you do it like AP, it should take 30 minutes. That's enough time for me to take roll, give them a 30-minute assessment, and have them grade their own because I don't want to grade them. So it comes with a PowerPoint that you can use. As soon as they finish, you can have them switch papers, and you grade this and score it according to the rubric. Every time I write one of these, each one, the entire 30-minute quiz is about one particular environmental topic. Like there's one on urban tree canopies. Yes, Jason, that is the Westwood High School parking lot where we both taught. There's one on reducing the carbon footprint. There's one on animal tagging. There's one on urban food forests. There's one on, I spent 3.5 weeks studying toilet paper to find out why you should be using recycled toilet paper made from bamboo that they sell at Target, or maybe you want a bidet. Lessons that matter will always be free. I'm not trying to make money. I'm not trying to make money on this. I'm trying to protect the environment and get some lessons out to you. Work will be added. If you do register, so I don't have to check if you're a teacher, if you could stop by the question leader room and just tell me, hey, I registered and I verified my email, that's an important step, then I can quickly open you up to more lessons. You can teach the whole course with a bag of M&Ms, but why not teach a lesson that matters or one that skews the script?
Thank you so much, Penny.
Okay, our last presenter for the evening will be Juan. Come on down, Juan.
My name is Juan Gomez, and I teach at Carmel High School in Carmel, California. And I'm here today to talk to you about the new Desmos statistics tools. Have you heard that they have new statistics tools? Yeah. So this is how I use them with my students in my classroom. So first of all, my experience is that my students understand the material. They understand it better when explanations are connected to visual representations. So in my class, we like to have discussions. So we're constantly asking questions. So what kind of questions can we ask? So I find that when discussions are had without visuals, the discussions and the questions tend to revolve around vocab, which is not necessarily what we like to do with stats. They also just like to memorize conditions. So the discussion questions are, what do I have to know? What do I have to show you? What's going to get credit? But the better questions, or with a hat tip to Dr. Alan Rossman, maybe the good and the better questions are, maybe they could be had by taking a look at maybe a binomial distribution and asking students, what are you thinking about? So some of the questions that my students ask are, why is it not continuous, right? Does it look symmetric? Why is there a value at 0? What's that about? And I have students, I doubt you have a student like the one that asks questions that always try to break things. But I had a student ask me, so what happens at 4.5? What does happen at 4.5? Not quite sure. So the other part that I like to do with my students is I like to form connections. So here you see both a binomial distribution and a normal distribution. So what sorts of questions can we get students to ask about the two distributions? So are the two distributions about the same shape? Are they? Some of the follow-up questions might be, hey, those p-values don't match. Why don't they match? And then my students are tinkerers. They will move things along and say, but I bet you I can make it match. So let me take that upper bound and start moving it up until they match, because I know it's just a hiccup, so let me move it a little bit to the right. Do the p-values match now when I move it to the right? What if I go a little bit more, right? And I told you about that student that always tries to break things, and he is persistent with his questions. So he still wants to know what is going on at 4.5. And then why do the p-values seem to get closer to there? What's going on there, right? So in my classroom, and I imagine everybody else does it better than I do, but inference is hard, and it's hard for students. So I find that for my classroom, students will mimic what I do, right? But they don't really understand what's going on. So how do we get them to better understand what's happening in inference procedure? So some of those questions that I ask of myself is, how do I help them better understand all the little bits and pieces that go into an inference procedure? So one of the places I like to start is, let's just take a look at a distribution that we might find ourselves doing inference upon. So what is a chi-squared distribution, right? So what is it? Well, here it is. Meet the chi-squared distribution. And students, instead of just telling them what they're noticing, I like to ask them, what do you notice? What do you notice about the chi-squared distribution? And inevitably, somebody will say, oh, it's got that hump, but it's off to the left. Or they might say it's skewed right, and it always seems to be skewed right. But some of them noticed that there's a peak. There's a peak there, and they're looking at the degrees of freedom, and they're saying, why is the peak too off from the degrees of freedom? Does it always happen? Well, they're tinkerers, remember? So they will say, let's increase the degrees of freedom and see if that stays the same. Does it stay the same at 8? But we know that doesn't prove anything. What if it goes up to 12? Now we have something where you're opening a door for them to inquire about what's going on with chi-square distribution. But again, inference is hard. Inference is difficult. So how can we show students what's happening inside of an inference procedure? So the question I ask is, how do I help them understand all of the little bits and pieces one at a time? So here you have, and I'm not sure how much time you spent with the new Desmos tools, but this is part of the inference wizard, where you can choose a variety of probability distributions. You can choose to create, what I've done here is a chi-square test. So I was able to put in some data taken from our friends at Open Intro. They allowed me to use this question from the Advanced High School Statistics textbook, the 2nd edition, where a place you might use it is, perhaps Google has a search algorithm. You can see that to the left, group 1, that they're currently running, and they're testing out a couple different search algorithms. Are the new ones better than the other ones? I was secretly hoping for that. Bucket item filled. So the things that they might want. They know from me that they need to have expected values. Sure, there they are. They might have totals, right? Because the piece of paper you put in front of them asks for that. But the contributions piece, how do we see all of these things all in the same spot? Which of these values contributes the most to the chi-square test statistic? It's pretty in your face. I hope you would agree on that. And then put the whole thing together. How did these values here help you see the p-value, the chi-square, along with the graphic all in one spot? And then ask the questions you really want to ask is there something unusual here? Is there? Well, then you quickly notice that there is. You can see it in blue. But they're tinkerers. So they're going to want to know, well, what if? What if I play with that one spot that's contributing heavily to the chi-square test statistic? What if I make it 701? What if I just mess with that one little spot? What if I make it 901, right? The what if question, I think, is where we all want to be. What if? So my takeaway is that you can...
You not like Hulk angry.
I like that. The takeaway is you can open doors for student understanding by allowing them to see what is happening in an inference question, and then allowing them to tinker. Thank you.
Thanks again. Good job, Juan. Appreciate it, bud. Thanks, man. Thanks, Juan. Hey, let's go to that one more time for all our presenters. Fantastic. So I encourage you, when the emails go out in the spring, look for the invitation to do best practices. If you've got something you're doing in your classroom, we'd love to hear about it. I got a little giveaway. I made a presentation last year about using a can of Avengers to teach confounding, stratification, that kind of thing. So there are 3 separate sticky notes underneath the chair. So if you guys find a sticky note, I got a prize for you. And then Bridget's going to close us out.
There we go. We got all 3. Okay. Before you head out, just so that you are aware, we're going to ask our presenters to kind of stay up here so that if you have any questions or you want to chat with them about anything that you saw, feel free to come chat with them. Please be on the lookout for all of the presentations to be posted on Bob's website. It's going to take me a while to combine everything into one video, but their presentations will also be there. So thank you so much for coming, and we look forward to seeing you guys next year.